This video is a continuation of the discussion of the chemistry of the alpha carbon. In this case, we're going to combine two aldehydes after the deprotonation of an alpha hydrogen to create an enolate to synthesize what we call a beta hydroxyaldehyde or a beta hydroxyketone. The acidity of a proton that is bonded to an alpha carbon is a lot less than that of the hydrogen that is bonded to the carboxylate group of carboxylic acids. However, it is an sp3 carbon hydrogen that is more acidic than any alkane. The first step of the Aldol condensation reaction is the deprotonation of the alpha carbon hydrogen to create a stable enolate. Methyl hydroxides, such as sodium hydroxide or potassium hydroxide, are used with ethanol, and the byproduct is just a removal of a molecule of water. Recall that in alkylation of the alpha carbon, stronger base as LDA was needed. The base is used to produce a portion of enolate that will work as the nucleophile to attack the carbonyl of the rest of the unreacted aldehyde or ketone. Recall that aldehydes will undergo addition reactions. Once we attack the carbonyl that is partially positively charged, we are going to create an intermediate tetrahedral that will need to be protonated by the solvent. Protonation of the intermediate alkoxide form on the beta carbon will regenerate the catalyst OH-. Depending on what is the need on the synthesis, you can keep the beta hydroxyaldehyde or ketone, or you can further remove a molecule of water by dehydration to produce an alpha-beta unsaturated compound. Since the beta hydroxyaldehyde still has an alpha hydrogen, we can use the base that is regenerated to deprotonate the alpha carbon. The enolate form will trigger the removal of a molecule of water, but the hydroxyl group is a very poor leaving group, so it will need to be protonated to produce an alpha-beta unsaturated ketone. Or an alpha-beta unsaturated aldehyde. In this example use, our product is 2-ethyl 2-hexenaal, which is an alpha-beta unsaturated aldehyde. Now we discuss the cross-aldol condensation, which means that we can use a ketone and an aldehyde, two different ketones or two different aldehydes. In this example, we are going to create a chalcone by reacting acetophenone and benzaldehyde. The first step of the reaction is the deprotonation of the alpha carbon of acetophenone to produce an enolate that is stable by resonance. We can observe that the two electrons on the alpha carbon of acetophenone are delocalized between the carbon and the oxygen. So we are seeing here the flow of electrons between two resonance structures. After formation of the enolate on acetophenone, we are going to have an addition reaction to the carbonyl of the aldehyde. The intermediate tetrahedral form is protonated by the solvent. The product is a beta hydroxyketone and hydroxide ion catalyst is regenerated. Dehydration works stirring the solution for 24 hours or heating. The product of chalcone synthesis is a solid that can be recrystallized, is an alpha-beta unsaturated ketone.